Hi, welcome to A4 Cardiac System. We're still looking at responses of the body to one single bout of exercise, and today we're going to be looking at the anticipatory rise. We're looking at cardiac output, heart rate and stroke volume and their relationship, Starling's law, blood pressure changes within aerobic and anaerobic activity, redistribution of blood flow to active and non-active parts of the body, change in blood pH with exercise, diffusion rate of oxygen and carbon dioxide at rest and with exercise, and finally the artery and venous oxygen difference, arteriovenous oxygen difference. Do you remember the last time that somebody frightened you or made you jump? You may have been engrossed in a film that you were watching when somebody just comes through the door or knocks on the door. You put your hand to your heart and you can feel your heart rate increase rapidly. So we need to look at why this happens. It happens to get us ready for exercise. It tries to increase heart rate, therefore increasing the oxygen, and will also help to get rid of waste products like carbon dioxide. So essentially it's getting us ready for exercise because it knows we're going to get up and do something. You don't feel this all of the time. So if I said, we're going to do a PE lesson, then some of you wouldn't feel a rise in heart rate. Some of you would, those that were excited about going out to do sport. If I said to you, you've got your driving test tomorrow, and that was quite possible, you would feel that rise in heart rate. So it's when the body feels threatened almost, or it knows it has to perform for something. You will get a response of adrenaline. So it's called the anticipatory rise as well as the fight or flight response. The anticipatory rise is the key word that you should use in your exam papers. So we've established that heart rate needs to be increased along with the physical demand of the exercise. So if the physical demand of the exercise is light, i.e. you're going for a walk, then the heart rate needs to be increased, but not by very much. If I'm going to ask you to do hill reps, then the heart rate would need to increase significantly more because the physical demand of the exercise is more. So the rising heart rate is required to deliver increased levels of oxygen. It needs that oxygen to get delivered to the muscle cells, the working muscle cells, to produce energy and muscle contraction. When that muscle contraction occurs, we produce carbon dioxide, so that needs to be removed because we can only have so much of that in our blood. If this is ringing bells but you're not quite sure about it, go back and listen to some more on the respiratory system, section A3, to refresh your memories. The rise in heart rate prior to commencing exercise is known as the anticipatory rise. So it occurs before we've even started exercising, just because our body knows we're going to do something and knows we need to get ready for it. The anticipatory rise is caused by the sympathetic nervous system. So I like to remember the sympathetic nervous system as the things that speed things up, the things that get things going, and speeding things up and sympathetic both start with a S. The nervous system, this sympathetic nervous system, releases the hormone adrenaline into our bloodstream. The adrenaline in the blood is picked up by the chemoreceptors, if you remember them from section A3. So they're the specialised cells laying on the inside of the arteries that detect a change in chemicals of the blood. And that change in chemical is the hormone adrenaline. So it reads that there is adrenaline in the bloodstream, sends a neural message up to the medulla oblongata, and will increase heart rate. So let's recap. Adrenaline is a hormone. It's released via the sympathetic nervous system. It makes the heart beat faster to get us ready for exercise. The presence of adrenaline is recognised by the chemoreceptors, those specialised cells in the arteries, and the information is taken via the central nervous system, via our sympathetic nervous system, to the cardiac control centre. That's in the medulla oblongata, and if you are not sure of that term, please go back to section A3 and have a listen. But essentially, the cardiac control centre works in a very similar way to the respiratory control centre. And of course, they've got to work together, because if we get an increase in breathing rate but not an increase in heart rate, then we cannot take more oxygen into the body and we can't get rid of carbon dioxide, because we might be breathing faster, so we're getting access to more oxygen. But if our blood is like the train, our blood system, it's the one that moves it around. So if the heart rate hasn't increased, your blood flow hasn't increased, it's still slow. So therefore you can't pick up, you can't absorb and utilise that new oxygen. And likewise get rid of that carbon dioxide. So this is an exam question. It comes up quite often from the papers that we've seen. And it will ask you to track the heart rate and make suggestions as to why the line is the way it is. So let's have a look at this line here. So we've got heart rate, so the number of beats per minute up the side. And we're looking here at about 60 beats per minute on this person here. That's their resting heart rate, because we're in the section of before the swimming race starts. Now let's draw your attention to this important part here. This bit where there's a slight rise in heart rate prior to even starting the swimming race. That is our anticipatory rise. All right, so this is the slight increase here. We know now it's caused by the hormone adrenaline. After or during the swimming race, when they've just dived into the water and they've started here, we've got a dramatic increase. All right, so a fast increase at the start of exercise. And then it plateaus. So a steady plateau only occurs if the physical demands of the task are also steady. So if you are working no harder or easier, it's continuous exercise. So let's say it's a long distance swimming race, or it is a jog, a recreational jog, then you will see this plateau. If, however, the demands of the exercise are increasing all the time, and then they suddenly decrease and then they increase again, you would expect to see a similar pattern in heart rate, because it is directly related to the demands of the physical exercise. So exercise has now finished, and there is quite a sharp decline initially, followed by a bit more of a steady line. But you'll notice, in fact you might not notice on here, but it is slightly higher than the initial resting heart rate. So why is that? We've got this steady decline. So it does decline because the demands of the exercise have reduced considerably, but it hasn't gone right down to the resting rate, because we need to recover. And to recover, we're still producing carbon dioxide, or we've got leftover carbon dioxide from when we were working really hard. We've got an oxygen deficit that we need to replace because we had to borrow some things when we first set out, when we were all out of breath. So it's just to collect that extra oxygen and get rid of that extra carbon dioxide, even though we're not exercising anymore. So it makes up for the shortfall we had when we were back over here and needed it really, really quickly but couldn't get it. That's all for the anticipatory rise.